Hello and welcome to week 9 of Genomics in the Cloud Book Club. I'm your host, KT Picard. In today's meeting, we'll be discussing Chapter 8, Automating Analysis Execution with Workflows. We'll be moving from the commands we've had in the last two chapters, doing variant calling for single genomes to working at scale. We'll go through a presentation today with our guest speaker, and we'll go through some additional resources with plenty of time for open discussion at the end. So this week it's my pleasure to introduce our fourth guest speaker. We move, as I said, from running individual commands in the terminal to automating that workflow. We're honored to have someone with extensive experience building usable genomic scale cloud pipelines. 10 years ago, she started her own consultancy. Her clients include the Broad Institute, CZI Science, Imperial College of London, CSIRO Bioinformatics. She's the author of over 30 courses on LinkedIn Learning and has received multiple awards, including Microsoft Regional Director, AWS Community Hero, and Google Cloud Expert. Her open source courses on GitHub include GCP for Bioinformatics and Learn Whittle. In addition to her work in bioinformatics, our speaker is the co-founder of Teaching Kids Programming, a volunteer organization that introduces core computational thinking to a new generation. She has a degree in linguistics and has taught cloud architecture and bioinformatics to thousands as her role as a global educator. Please welcome Lynn Langen.
Good morning, everybody, or wherever, afternoon, evening. Thanks for joining. I'm going to go ahead and share my screen and get started. So let's start by thinking about this language WDL, or workflow definition language, and how it works to scale our genomics work. So the language itself is what's called a domain-specific language, and it was originated at the Broad for scaling genomics work, most often using GATK tools. The Broad open sourced WDL, and there is now a group that works on the language specification, and the language itself is open source. The language includes a number of tools, one of which is particularly useful when you're learning. It's called, I don't really know the name, so don't blame me for the names. It's called the WOM tool. We have some ex-Brodies on here, so maybe they can explain some of these names, but that is a WDL parser. There are also other tools, such as a WDL linter, and these are grammar tools, basically, that when you are authoring or writing your WDL workflow code in a tool like VS Code, it will help you, it will guide you. In this talk this morning, I'm really going to focus more on running WDL that has been written. Now, as was mentioned, in combination, well, really for the Broad, I wrote an open source course that's on GitHub, Learn WDL, that really takes many of the examples in the book and either adds some intermediate steps or add some steps beyond. So it kind of builds beyond the book. And this is one of the reasons I wanted to be a part of this group, because I'm really interested on anybody feedback here, because, you know, you, as an instructor, you work hard to make what you think will be good for the students, but I am not a researcher, I'm a nerd. And so I gave it my best shot. In addition to the WOM tool, there is a tool that comes with WDL. It's called Cromwell, and it's an execution environment. It's Java-based, so it is, physically it's a jar file. There are other execution environments, and we can talk about them in the comments part of this presentation. Now, it is possible to run a WDL script with Cromwell by itself, but more typically, you're going to run that on some sort of environment. It could be your desktop for testing. It often is an HPC cluster, but very specifically to what we're covering here, it also can be the public cloud, including Google Cloud. So before we get any more into the execution environment, let's really look at a high level how the WDL language will work to string your tasks together. And by tasks, I mean GATK tasks or just scripts, basically, whether they use bioinformatics tools like BLAST or something, or whether it is a script that you write. So conceptually, this is a high level of the way WDL works. On the left side, you see you have a task, and the task in yellow has some variables defined, and there's strong typing on the variables. So you have to define what data types they are: strings, integers, files, and it's Java-like, but it is its own thing. It's not the same types as Java. And then you have a command, and here we're showing do stuff. And this could also be the GATK command. You'd have to have the GATK jar file, of course. And where you might put that is in the next section where it says runtime. Most of the time when you're in production, you will use a Docker container. Certain environments, such as GCP, with some of their tools, require Docker. So it's more and more a practice that you will encapsulate GATK or whatever commands you use in Docker, and then you specify where the output is. Now, the way the workflow side of WDL works is you can see on the right side, you call the task. Now, in the WDL language, you can just make a really long script, and you can have the workflow with the variables and then calling the task and the inputs and then calling the next task. And then you can have the task definitions below it in the same workflow. Or more commonly, you will put the task definitions in their own file, their own WDL file, and then you'll use the keyword imports to reference that other file. In the examples that I'm working with, because they're introductory, kind of everything's in one. And that's a little bit artificial, because in production, it's more usual that you'll have the task references in a set of files, and then you'll have the workflow calling them using import statements. So we pretty much talked about this. So we have workflows. Each time you run a workflow using Cromwell, you get a job execution identifier or a GUID. It's a folder, basically. And that folder has child folders in it, one for each task. And it uses however you define, but generally you start with the pattern of standard out, standard error, and you're going to see succeeded in the logs. Cromwell, the execution environment as default for WDL, is very, very verbose, as we'll see in a minute, kind of almost overwhelmingly verbose. And of course, it has a verbose flag if you want even more. But the reason for that is because you're getting ready to run this at scale. And so you really want to understand what are the resources needed in whatever execution environment. So the CPU, the RAM, so on and so forth, so your tasks can succeed. This center point task must be optimized. I cannot emphasize this enough from real world work. I'll give you an example. I was working with a client and they had written all their tasks in the R scripting language. And it was working great on their desktop, but when they were trying to run this at scale, it was bottlenecking, because when they're putting the amounts of data that they really needed to analyze, the R language, as you may know, is single threaded. And so it just basically would block until it got done. And in their case, in their shared execution environment, they got kicked off the HPC cluster. So that's like a really common thing. So that's why Geraldine started the book with GATK, because the tasks have to be optimized first. And then of course you're running the tasks where often in containers, and the containers have to be optimized. So this really, from a learning standpoint, it kind of goes like this in terms of the book content. So again, I'm going to try to give you a learning ladder, but if you're feeling like the ladder is pretty steep, that's common at this point. I love to draw. I'm a software architect, so I don't know if this will be helpful or what, but when I am working on a computational environment that involves analyzing large amounts of data, there is a pattern, and it's called a data lake. So the data lake pattern is really kind of where we're going. And you can see there's really two major sections here. At the bottom, we have the data, and at the top, we have our compute environment. Now, when we first start working, because I'm a cloud architect, I work in a way that might be new for some of you. I don't use my local machine for anything other than basically a dumb terminal, as you'll see. When I start working on a cloud solution, I start on the cloud. Now you'll notice on the top, we have only one machine. So that isn't really very scalable. But, you know, the point here is that once you want to scale, you simply add more machines. But this little fact of starting on the cloud rather than starting on your desktop is a pro tip. Because if you start in whatever environment, it's much easier when you want to start scaling. Now you'll see on the right, we have 4 jar files. Setting up to run a WDL script, I think, is a little bit of an intimidating process. And hopefully if I've done my job, I'm making it a little less intimidating. When I was breaking into this a couple of years ago, I basically couldn't figure it out. And so I approached the Broad and I said, the documentation, you know, maybe I'm just don't have enough background. And so they said, well, why don't you write the documentation? You know how that goes. You make your request. And so now I've written this course. But you do need, in the Cromwell world, to have 4 jar files and configure them correctly, which I've already done in the environment we're working on today. But you know, when you first get started, you do have to carefully read the instructions. And then you will have your data that you're going to analyze that's going to be stored either, in my case, in Google Cloud Storage buckets, or, you know, if you're running this locally in the local file system and the output goes to another destination in the file system. You will also have configuration. Okay, enough conceptual. Let's get to something actually a little bit more practical. Now, earlier in this book, you were working with a Google Cloud VM, and I am as well, but I have a little bit different twist on this. Rather than just creating a raw instance in the Google Cloud, a Linux instance, and then getting those 4 containers and then figuring out how to put, you know, figure out the Java environment, figure out where Cromwell is, figure out how to, you know, configure all that. I always like to make it a little bit easier if possible. And so I created a VM, but my VM is got some stuff on it already, basically. So in Google Cloud and in most of the modern clouds, because so many people want to use Jupyter notebooks, you can create VM instances that have a bunch of things on them. They are slightly more expensive, but when I say slightly, I mean 50 cents an hour versus 10 cents an hour. So, you know, this is just, again, a tip. In this particular case, because I'm testing something else, I'm actually using a machine learning framework called TensorFlow. But typically for bioinformatics work, I'd use either R or Python. And it's super handy because it already has Docker on it. And then, you know, if you've got some R, it already has R on it. So if you create one of these, you can go in. And another thing about this is you can set a little bit larger environment. And you can see over to the right, it tells you how much it's going to cost. So for example, many times in production, I've got some tasks that are memory bound because they're doing a lot of machine learning. And so I can use these more performant instances even in testing, and it just comes back faster. You know, I mean, when you're testing a workflow or a set of tasks, if it can run more quickly, then you can have a faster loop for optimizing. So again, just another tip from the real world. So in this case, I'm going to use Jupyter Lab as my way to interact. So what I have done here is I have prepared this, and I could use a Jupyter notebook, which I would use most often in any sort of real world scenario. But because of time, I'm just creating a terminal instance. But again, one of the things that I like to do is I like to change any of my scripts into Jupyter notebooks because I do like the fact that you can put markdown in them and that you can put visualizations in them. And I find that to be really useful. All right, so now kind of the nitty-gritty stuff. I went to my Learn Whittle and I got the examples. And the examples here, like I said, are everything in Geraldine's book and more. Also, everything that I'm showing you, I have recorded. So so if you, I call it Lynn TV. If you want more Lynn TV, when you're done with this, I have more. Each of these is recording me showing all these Whittle concepts. So the first thing you want to do is you want to make sure that you're in the right place. So again, like I did a couple things that just make it easy that you wouldn't really do in production. I put everything in the same directory. So you'll see I've got WOM tool here. I have Cromwell here, and notice they're versioned, and you would download these from the Broad. To do the testing in this environment, you need to have Git, Java, Docker, Cromwell, and WOM tool. So again, just made it super simple. You just go over here, and I won't do all of these, but you'll get the point. And you need to verify that you have, the various parts and pieces, if you will. Now to test Cromwell, I'm using sudo because of permissions. I just didn't bother to change the permissions. And I don't need it twice though. So to test Cromwell, Cromwell requires a Java runtime. So you have to say, using Java, use this Cromwell utility, which is, if I were naming things, it would be called the WDL runner, but I'm not, I'm just using them. That's what it does. It runs a WDL file. So you have to test it, make sure it's there. And you can see Cromwell 54. And let me just clear this out. So now your first Whittle file. I like to start with a hello world because I'm got that sort of nerd thing going on, which is obviously very artificial, but you can see that you have the workflow, which does one thing. It calls write greeting. And then you have the task, which does one thing. It echoes hello world and it writes it to standard out. This is a typical pipelining process where you write it to the terminal and you write it to a file location. So again, massive overkill to use Cromwell to run this. Now Cromwell has two types of run modes. It has what's called run, and run means execute the instructions in one Whittle file using the Cromwell set of services. And Cromwell is a job runner. The other mode, which is used in production, is called Cromwell server and requires a separate, basically virtual machine that takes all the various submitted Whittle files or jobs, looks at the resources on the execution environment or cluster, and schedules them. So when you work with Cromwell in production, you either set up a Cromwell server or kind of going to where the book is going, you use a environment like the Broad's Terra.bio, which encapsulates a Cromwell server. You don't even have to see it. You basically submit your Whittle. They have all that. You submit it through the web UI and it goes on to the job queue and you see it in a graphical interface. But we're kind of at the low level here, looking at all the guts of it. So anyway, so how do you run this thing? Well, what you do is, I don't know why I have the double sudo there. I must have done a destructive edit. At least I'm noticing it. Let me just move. So you say sudo java jar Cromwell, start the execution environment, and then you use the verb run because that's a single instance run. And then you run it And something I like about this execution environment is you see over to the left where you have the file structure over here. So if I go into Cromwell executions, the name of this workflow is Hello World. And you can see that I have some of those execution results here. And you'll see in a minute that you'll have another one. And this is what I mean about those folders. I just like this for testing because rather than using, a plain terminal where you then have to CD and you can see it, this is where you're going to see the results, as well as over here. So as I said, this is pretty verbose, so don't let that scare you. You can see it starts up here and then it does some stuff. Okay, and just does some stuff. We'll come back to what it does some more stuff. Green is good, red is bad. And what's really good is if you get succeeded. That's what you're looking for, succeeded, okay? And in this case, you've got, where is it here? In here, you have the hello world. So the output hello world, and you can see there's the directory. It's written to standard out. Okay, so now, and you can see a minute ago, here it is. We go in here, here's the one task. Inside the task, the execution, and we have standard out. Hello world, yay, so happy. From a practical point, standard error, you'll be going there often when things don't work. So that's where the errors go. So again, I like this, this is what I actually use when I test. So I always like to show people what I actually use. This is not what the book uses. The book uses terminal, like, on a single VM, but I don't know. I just, I like to use this. So, all right. So now we've got the hello world. We need to get something a little bit more realistic. So let's clear this screen out. And the next thing that we want is something with Docker. So I'll show you what that looks like. So it's pretty simple. So basically the only change is here in the runtime, rather than running on the execution environment, which in this case is a VM, we're going to run in a Docker container. And the way this works is if this is the address, then it pulls it from the registry, the default registry, which is Docker Hub, which is a public registry, kind of like GitHub, and the image has to be public and available. This, of course, is a Linux image. So oftentimes you will not use one of these public registries because it's not as performant. So for example, in Google, you'll often use the Google Container Registry, Amazon, the Amazon Container Registry, Azure, so on and so forth. So again, it's part of the process of moving your workflow to the cloud, which is you need to, write your task or use GATK. You need to then figure out where you're going to put your container and put your container in its location. And then you need to write your WDL. So there's multiple steps. Now, if we run this, it's going to look really just like the other one. It's going to be kind of transparent because it's the same process. Obviously we'll have a different folder, but it's the same process. Other than it is physically running in a container. And again, notice when you do Cromwell run, the run will start, it'll execute whatever instruction is in the WDL, and then it will stop. And this is different than Cromwell server, which is the server just stays on and then it waits for jobs to be submitted. And of course, what are we looking for here? Green and the word succeeded. There it is. And then if we wanted to look at it, we would just go back here and we would go into the Cromwell executions and the hello world with Docker and the folder. And I'm doing this on purpose because if you're like me, when I first was getting into this, I am not embarrassed to say I couldn't find where the result was. it took me a while to find it. And I was like, where's the result? I don't know where I am in all these folders. So, that's the way the system works. All right, so now let's move on to something that's a little bit more interesting. So the next thing is we want to start working with inputs, because our files will have inputs. So the hello input file here. So the hello input file in the task section takes a parameter. So you can see the workflow has a parameter defined in line 4, and then it's assigned in the task call in line 7. It's also, the parameter is defined in line 13 and 14. And then in line 19 is where the parameter is actually used. And notice the format, $, curly name, $. Now, when you are running a WDL file with a required parameter, you can either assign that on the command line. So you can just add that as a parameter on the, Java jar, Cromwell, blah, blah, blah. But what's more common is you will actually use a separate file to define the parameter, or more commonly parameters, because in bioinformatics, you often have 10 or 15 or 50 parameters. So what does that look like? So in our case, it's really simple. You just have the name of the workflow, and in this case, the name of the variable. Now you can assign the variable at the task level, so then it would be the name of the workflow, always case sensitive, the name of the task, the name of the variable. And then when you're running this, rather than saying the name variable is this, you point to this workflow, to this, this parameter file. So what does that look like? Let me just get a new terminal and I will show you. So the command for this is here. And let's just, first we'll look at the command. So you can see sudo java jar cromwell run hello input inputs, and then hello input JSON. Again, I want to point out, I'm making this simpler because I put all files in the same directory. If you had to do file paths, that would make this command longer as well. But I just wanted to, distill it down for learning. So now we're going to expect that this hello inputs file is run as part of the workflow. And it says, unable to access the jar file. Why? I'm in the wrong directory. So again, this is part of setting up your environment correctly. And you could, of course, set up pathing for this, but I like to take the easy route when I'm demoing. So just put everything in one directory, start there. And again, we're looking for the familiar green text and success. Which now, if we went into the execution logs, we're in hello input. And I know I'm doing this lots of times, but you'll thank me when you're actually working with it. There it is, yay. All right, so now, let's look at the WOM tool. So I said the WOM tool validates. What does that mean? Well, in the case of this hello input file, if instead of saying Cromwell, we say WOM tool, and then we WOM tool, just like Cromwell says Cromwell run or Cromwell server, WOM tool has a bunch of verbs, and one of the verbs is validate. So if we say WOM tool validate, what does that do? Well, great. What does that mean? Well, that means that there is, the syntax is correct. How can we know this? Let's break it. That's always a fun way to know. So let's put an S here So the call does not match the task. And say save. And now let's try revalidating it. And of course, we would expect that our error would be shown. And it is. Failed to process workflow definition, cannot generate output for call write greetings. No such callable exists because we're trying to call a task that's not defined. Which you might say, well, that's, why do you need a tool for that? Well, when you have a WDL file that's 700 lines long, you'll be happy to have that because there are other errors that WOM tool will catch. Now, another thing that WOM tool can do is it can generate these inputs. So it has a verb called inputs. And, we worked with that input file because it's a common pattern when you're working that you won't write a WDL, rather you'll find a WDL and you'll say, okay, this WDL contains tasks that look like they would match or be really close to what I want to analyze. Well, I wonder what kind of data or parameters I need to specify to run this WDL to try it out. And here you can see what this does for you is this generates in a JSON format that you can just copy and make into a JSON file that the particular WDL that has been analyzed needs this one parameter. So there are actually, with WOM tool, I think there's like 7 different verbs. So there's lots, it's just, it's a handy, it's like a little Swiss Army knife for WDL. All right. So now let's look at a really, an aspect of working with WDL that, to me makes it something that I use with almost every customer. And it's used in the book with the haplotype caller. And what I decided to do, and I'll show that, I guess, so you get the concept, is rather than show haplotype caller, because it's been covered pretty extensively, I decided to show this concept with a different set of tools because I think it's easier to understand as kind of an intermediate ladder and kind of leave haplotype caller for you guys as an exercise. And I'll be interested in the Slack. Hopefully you guys can say, yes, I was able to do it. But the point is, what you can do very easily with WDL is you can say scatter, which basically means run across multiple execution environments, multiple VMs, basically. So you can burst tasks that are computationally intensive. And again, you might say, well, gosh, this just seems like really obvious you would do this, but I will tell you from the real world, this is the key problem that I see over and over and over with people not getting good value out of cloud, is they don't implement this scatter if they're not using WDL, because it's really difficult in more traditional languages to layer this on top of tasks. So the way WDL works with scatter is it literally uses the word scatter. And then you associate it with a computational environment and it runs across and it's configurable. It's really elegant. I mean, to me, it's one of the key strengths of working with WDL. And I will tell you that this is an area that you really want to master to get the most value out of it. So given that, what I did is I created what I think is a simpler, so scatter Docker, simpler version, because haplotype caller to me is a hard one to learn on. And maybe that's just because I'm not a bioinformatician. I just need a simpler example. So I made one. Scatter Docker. Okay, so I need to go scatter Docker. You can tell I haven't had coffee yet. I am not a morning person. I'm doing this because I think I love this domain. All right, here it is. So All right, so you can see that the workflow at the top takes a sleep time. And when you are working with your task, which is called sleep, you simply use the scatter keyword. And again, hopefully it's pretty easy to understand that you're going to have how many partitions here? 15, right? Because what you're going to do is you're going to call this 15 times. Now, in this execution environment, it's not the most earth-shattering because we don't have 15 machines, right? But this will go across the number of cores that we have. And in our case, we have how many? We have 16 cores. So we will get a pretty good scatter on this because it will split across the cores. And you can see it's just a simple, sleep time. I slept 4, and then you go ahead and run it. Now, again, you might remember that on the sleep call here, you have a variable. So we could assign this directly on the command line, or we could assign this with an inputs.json file. So, and that's what we did. So you can see here. And here. Oops, I'm gonna move all this stuff around. There we go. All right. Okay, so our command here is, sudo java jar Cromwell 54 run scatter docker, because we're using Docker, and the inputs scatter JSON input, which I think I put 15 or whatever the number is here. And then we go ahead and we run it. And let's get ready to look at the results here. Scattering to me is always very exciting as a distributed architect because it means that computational resources are being used effectively. And again, in my work, that's really what I'm doing. I'm working with teams to get the appropriate amount of computational resources and get those resources to be used effectively and efficiently. So one of the patterns on bursting is these compute clusters are charged by the second, usually sometimes by the minute if it's really big instances, but often by the second. So you literally want to burst your task. You want to burst it out to the scatter and then come back down. And that's how you, number one, run your workflow, fast. And number two, you don't spend all your research budget on, cloud bill. So if we go in here and we find our scatter, timing workflow, there it is. And we call sleep, look here. These are our shards. So this is the scatter, you can see. All right. And then the last one, and because I probably just tell you because I'm running short on time here, is I just used a single tool. So I'll show you what it looks like, BAM stats. Because again, I think it's really important when you're starting to work with WDL that you start really kind of simple. And again, maybe that's my own background, but I use BLAST a lot because I know how BLAST works. And then I use BAM stats. And again, everybody has different experience. So if you're using haplotype caller and like every part of it, great, go ahead, go to town on that. But to me, it just was too many parts and pieces, and I needed to start with tasks that were simpler to understand WDL and to understand inputs and to understand validation and to understand scattering. And so I've got this BAM stats, which basically just is a single task, but it's a bioinformatics task. I've also done ones with BLAST, and I have those examples as well. All right. In the book, and again, I'll leave this for an exercise for you to do. One of the things that you can do with WAM tool, you have to install the GraphViz library. And you really do need this if you're going to be working through the examples in the book, because in this chapter and all of the next chapter, you are working with workflows and you're debugging them, fixing them. And it's going to be much easier if you use the WAM tool and then you generate these dot files, which basically show you what are the parts and pieces of the file so that you can figure out what it does and fix it. It's kind of a fun exercise. Now, to give you a preview of kind of why you're doing all this and where you're going with it, as you're moving through the book, sort of the next thing that you're going to see is you're going to see this data lake pattern, which here's your files and here's your compute cluster. And this part right here, this life sciences API, which is also called pipelines API or PAPI, this is the back end for Cromwell that Terra uses. That is from the Google platform that orchestrates the VMs. And the reason you do this is you work with a vendor's batch tool, basically, so that, again, when there is a request for more CPU, more RAM, more resources, then this API controls the bursting. And Cromwell, as a job runner, uses life sciences as a front end to this, to the life sciences API. So again, this is an area where I've done quite a bit of work. If you're interested in this, I've got, I should just go to this slide. I've got a bunch of articles. I just did work with Cromwell and Azure, for example. I published an article about it. And I've written some articles with Amazon Batch, along with some of these front ends as well. So anyway, so resources, Learn WDL YouTube playlist. Terra has great WDL documentation, as you would expect. My GCP for bioinformatics course is kind of where that came from is when I was at Broad, not everybody was using Terra. People were using raw GCP. And so I have this course on LinkedIn Learning GCP Essentials. And I said, why don't I just make this course, but make it with all bioinformatics? So like this course is like, I'm not using the Terra platform. I'm just using, raw GCP for some reason. So for example, I have a section on the GCP service BigQuery with, and everything in here is bioinformatics examples. So again, it's a resource that's out there in addition to, Learn WDL. And also within the Broad community, they have recently published WARP, which is a collection of highly performant WDL workflows that they use. And then there's the WDL spec. The biggest tip I would give you with this is allow yourself some time. It is quite challenging. Task optimization is super, super important, and try to find WDLs and run them and configure them as a first step, and move slowly into writing because it's deceptively simple. The syntax is easy, but getting the execution environment right requires a team, basically. So anyway, with that, I will be quiet because I can really run on at the mouth. So hopefully that was helpful for people.
Lynn, that was really helpful. Thank you for walking us through that. And I liked your examples very much. So thanks for expanding what was in the book and giving us some even additional insight. I'll post my question in the chat, and I'll kick off with one. This is around the workflow itself. So we went through the practical examples. I'm wondering if there's a way of tying this back in with the previous two chapters where we looked at germline and somatic variant calling or discovery. Are there, you said, some of the easiest ways to get started is to find a WDL and to modify it. And I'm wondering if there's a kind of a known repository or a place where these WDL files hang out, where where our members could just start. And now that we understand the kind of the basics or the block and tackle of running it, where do you go from there?
Yeah, so there is, and actually I'm really excited. Thanks for asking that question. It is called docstore.org, and Docstore is a repository of repositories, and it has organizations. So the Broad has an organization there along with other people, and it points to WDL files, and it has a visualization. And it points to tasks. So go to Docstore and search, and then try to run those. It also has a runner, a lightweight runner called Docstore CLI. So that's a great place. The second place would be, I would say, that WARP repository from Broad, but to me that's kind of advanced. Like you don't want to probably start there, but those are the real battle tested. These are, really solid. Of course, platforms like Terra, they're going to run workflows there. So you can find WDL files on Terra that are, the metadata is designed for researchers. So, and there are other platforms that run WDL too, DNA Nexus and many others. But I usually start with DocStore.
That's great, thanks. And Ian posted another resource on GitHub, GATK-workflows, as a place that he uses as well. This is great, and this is exactly the kind of information why we do book clubs, right? Is that we all learn from our previous experience and can share that. So I'm really looking forward to seeing an expanded discussion on Slack over the next week. We had some passionate discussions about unit testing over the last week inside of, in WDL. So I've enjoyed reading that. Our members have posted papers. Geraldine's online and also posted a kind of a list of best practices in workflow. Also, she did a review of it, and I posted the link there on Slack. I think that will, now that we've kind of gone through this and have an understanding of what it is that we're looking at, I think this will stimulate a lot more discussion now that we have a basis. So I'll pause there. Other questions from our members? This is a great way to kick it off. Thank you.
Yes, I have a question.
Please.
One of the first times I edited a WDL file that wasn't mine, I mistakenly thought the version 1 at the beginning of the WDL was something that person had written and just a comment. So I removed it, or I replaced it with version 0.1 or something like that. And immediately the script broke. But that reminded me that I had actually edited other WDL files that didn't have 1.0. So I was wondering, like, clearly there's a difference in syntax whether that version 1.0 is there or not. So I was wondering which one of the syntaxes is the most recent one and which one I should like systematically use, whether I should stick with version 1 or.
If I can jump in on that one. Yeah, so the version at the top of the WDL is a fairly recent edition, and it was introduced specifically for version 1 of the WDL specification, the language specification itself. And so it is now, basically, if you don't indicate the version, it assumes that you're using a pre 1.0 version of the language syntax. And there's some important changes. There were some breaking changes that were made when 1.0 was introduced. And we actually, we started writing the book when WDL was still in the version prior to 1.0. And in the last few weeks before publication, we had to scramble to update all the WDLs because we realized that we needed to live in the future and not in the past, which is a hard thing to do with language specifications in printed books. And the core team of OpenWDL has been working on a new evolved specification for WDL. There's a number of non-breaking changes that are being introduced, and it's a 1 point something. It might be even 1.1. I forget exactly where we're at with the numbering, but there's some new capabilities introduced that are non-breaking, and we're looking towards releasing a 2.0 with some breaking changes that introduce some more substantial capabilities. But yeah, so the version at the top there, and I realize we probably forgot to cover that in the book. So I'll make a note to add that because yeah, otherwise it's a little confusing for sure.
Thanks.
Matthew, thanks for that question. And Matthew will be presenting our next chapter, which is right, some deciphering some. We'll be delving into real world workflows and getting into some details. That'll be next time. Also, I just want to point out, Lynn, I really appreciate your bringing up Jupyter Labs. It's something I've just played with in the last few weeks. Kind of like your introduction to WDL, it kind of popped a internal 10 amp, maybe a 20 amp fuse the first time I tried using it. I did want to let our members know that there's a whole chapter on this coming up in chapter 12 as we get into Jupyter. But it was really cool to see you move around in that space. And it just, for me, kind of solidified why I'd want to get there and use it as a environment to work through these workflows. So anyway, thanks for bringing that into the discussion today.
Yeah, if I can jump in, that was really interesting to see. To caveat though, what we use in chapter 12 is Jupyter Notebooks, which is not the same interface as Jupyter Lab, strictly speaking. Jupyter Lab is a little more sophisticated. And in the book, we chose to just use Terminal just to avoid adding yet another tool. It's always like a trade-off. Do you use a tool that makes the thing technically easier, but then you have to introduce the tool and there's additional requirements and so on. So it's but it's really interesting to see the alternative in action. So thank you, Lynn.
Agreed. Yeah, no, it is a trade-off, and I think you've done a great job of providing things that always work. And I think that's the most important thing when you're trying these out, because as Lynn was saying, it can be really discouraging when you're learning something new. If you're fumbling with syntax or having troubles conceptualizing. Again, I found the examples very straightforward.
Thank you. Technically it's a low bar to say it like it's gonna work. You kind of expect it to work if you're buying the book.
You'd be surprised at some of the courseware that's out there, and I think a lot of our members are nodding their heads in agreement.
I'm going through another O'Reilly book where the author keeps changing how he's writing like Python commands, and it's just, if you're a total beginner, I mean, it's fine for me, but if you're a total beginner, that's like really confusing. So it is important. It might seem like a low bar, but actually there are people under that bar. So
well, I'll give credit to Brian. I know I show up here a lot, but Brian's the one who really went through the entire thing for consistency and checked that commands were written the same way all the time, and like with the same little, that we have a different character to start the line if you're in the terminal versus inside the Docker, to try to signify and give cues. Consistency is really tough, but full credit to Brian for making that happen on ours. I was going to add one thing on the haplotype color as the example for Whittle. I'd love to hear feedback and impressions from people, because we chose that because it's kind of in the continuity of the book, because you technically learn a lot about haplotype color and you use it in at least 2 chapters. But I can totally see how if you came to it just independently without having worked through like 5 and 6, an alternative is conceptually simpler, because haplotype color is a little tricky. Just be interested in feedback on Slack at some point. We don't have to take up all the space. But yeah. Thanks again, Lynn, for showing another example that'll be accessible for anybody who comes in without having looked at the rest.
For sure. Well, that's sort of my thing. Learning ladders. Any language, any environment. That's what I do.
Fair enough.
And do it well. I was very impressed with the coursework that you put together, including most recently how to build a profile inside of GitHub. Was one of I saw your most recent teaching courses. So I think, yeah, I was very impressed with. In fact, my son's now putting his code on GitHub, so I think that's something I'll be sharing with him. It's like it's his calling card, and so.
Well, I work with a lot of apprentices in my consultancy. I have this thing of bring someone with me, and I launch them off into other careers. A lot of atypical, because I'm atypical. I don't have a CS degree or anything. And I want to bring more people into computational bioinformatics because it's great. And so I have, just informally in helping people transition from working part-time with me to full-time jobs, help them with that. And somebody said you should make a course on that. And so I'm really glad to hear that you found that useful, because it's a really short little course just launched. For those of you who haven't seen it or whatever, I make courses for LinkedIn Learning. It's called Great GitHub Profiles. And it's an actual one of my students that worked with me. He just graduated from BYU with a degree in math. So I looked at his profile. I said, that's pathetic. We need to do something. And we made a course on it. And he got a job, which is, I don't know if
Wow.
it's because of that, but he got a full-time job, which is kind of great.
Well, proof's in the pudding. That's wonderful. Great.
Yeah, I'm glad to hear that.
Yeah.
I would say that this is a valuable skill set to have in today's economy. Like, anyone who's willing to put the time in to learn a workflow language is going to really benefit in the long term, because I'm speaking from personal experience. It's really helped me like make my way in a field where generic bioinformatics is like opening up a command line and running a program. It's like, that's just not going to cut it with all the big data. And my most recent position involved a lot of NovaSeq data, and you can't push it through a regular systems. This is why Geraldine's book and Lynn's training materials are just so invaluable. And I really appreciate your guys' time, for this book club. It's really, really been worth it. Thank you.
Yeah, thanks, Adelaide. Yeah, and one of the things, I think we'll pick this up again on Slack, I've noticed is that we've had discussions around Whittle versus SnakeMake, Nextflow, and all these different workflow tools to get the work done. And I think one of the things that I'm learning is, if you're working with single genomes versus multiple, if you're working in research versus clinical, there's kind of a matrix there that makes people move or gravitate towards certain workflow environments. And I just want to point out that it isn't always the case that one size fits all. And I think our members have shown that they have different reasons for exploring different ways of getting work done. This one, Whittle, I think, is certainly the most well developed, and certainly from what I've seen so far, the one that would be the most applicable to running things at genomic scale, or instead of astronomical, genomical, right? In terms of just that much data. But I did want to point out that that is an ongoing area of discussion. If you're joining us on YouTube, you can't always see what's going on Slack, but there's a very active discussion about different workflow environments.
I should probably mention, because I just created a course within a course on another alternative tool to Cromwell. It's called Mini Whittle, that people might find interesting. And I've got like 4 or 5 little screencasts on it as well. It's more of a quick get it up and going type of thing. It's Python based, so no Java. So it's embedded within the Learn Whittle course. There's a section called Mini Whittle. So again, if you're really more inclined towards the Pythonic world, it's another way to run Whittle scripts, different execution environment. So
yeah, and I would say I would add to that I think it's going to be a really useful tool for people to learn Whittle and learn to use it and learn to develop and write their own Whittles without having to deal with the complexity of Cromwell, because Cromwell is designed and developed for a production team at the Broad. And so it's for professional data engineers who do this 24/7. Well, maybe not, but work-life balance. But it can be hard to deal with Cromwell sometimes, but Mini Whittle is a really nice alternative as a Whittle executor that I think in the future we'll probably pivot to using Mini Whittle for tutorials and things like that. But then you can learn enough and develop your Whittles and then still run Cromwell in production for the really heavy duty stuff. I think that's probably where we're going to head as an ecosystem.
Yeah. So yeah, I agree on that. So just to add like a bit, yeah, it's kind of a like any of this domain specific language. Like once you learn one thing, then to migrate to the another thing, it's not very time taking, because I'm coming from a Nextflow background, and recently I started using Whittle, and the concept is almost same, right? You just need to learn the input and output, how to configure, and the runtime environment, how to configure it. Otherwise, it's the same similar steps in a particular part, basically. So yeah. And true, some are well designed for running in a production grid, and some are well designed to quick start the job, basically, right? Yeah.
Thank you for that. And I look forward to learning about Mini Whittle. And then I'm assuming that's part of your Learn Whittle on GitHub. Is that right?
Yes, that's correct. There is a folder that's basically Learn Mini Whittle. This is number 6, basically. I can put a link in the Slack.
Fantastic. That'd be great. Okay. Well, we need to call it a day. It's been a wonderful hour. Lynn, thank you so much for your time and teaching us about Whittle this morning. I really look forward to continuing the discussion on Slack and meeting everyone next week. Thanks for joining us and have a great week.